Hello everyone, welcome back to Ekraft Geeks. Today we will be learning on the topic I2C Bus. As you see, here are the following contents on what we'll be doing on today's topic. The contents include introduction, working, specifications, advantages, disadvantages, and its applications. So let's begin. Let us start with introduction and know what is I2C bus. An I2C bus is a synchronous multi-master multi-slave serial communication bus that is widely used for attaching lower speed peripheral ICs to processors and microcontrollers in short distance intra-board communication. I would also like you all to know that I2C bus is commonly known as I2C bus, which is a full form for inter-integrated circuit. Now let us know about the working of an I2C bus. So how does an I2C bus work? The I2C bus is a standard bidirectional interface that uses a controller known as a master to communicate with slave devices. A slave may not transmit data unless it has been addressed by its master. Each device on the I2C bus has a specific device address to differentiate between other devices that are on the same I2C bus. Many slave devices will require configuration upon startup to set the behavior of the device. This is typically done when the master accesses the slave's internal register maps, which have unique register addresses. Here's a general procedure for a master to access a slave device. Suppose a master wants to send data to a slave. The master transmitter sends a start condition and addresses the slave receiver. Then the master transmitter sends the data to a slave receiver and the master transmitter terminates the transfer with a stop condition. However, if a master wants to receive or read data from a slave, the master receiver sends a start condition and addresses to the slave transmitter. Then the master receiver sends the requested register to read to slave transmitter. A master receiver receives data from the slave transmitter and then terminates the transfer with a stop condition. Hence, after learning about the I2C bus and its working, let us know its specifications. The specifications of an I2C buses are: the I2C bus uses two wires, that is serial data SDA and serial clock SCL. All I2C masters and slave devices are connected with only two wires. Each device can be a transmitter, a receiver, or both. Some devices are masters. In order to communicate with specific device, each slave device must have an address which is unique on the bus. Let us now go to advantages and disadvantages of I2C bus. In advantages of I2C bus, I2C bus maintains low pin or signal count even with numerous devices on the bus. I2C bus adapts to the needs of different slave devices and readily supports multiple masters. I2C bus also incorporates AC or NACK functionality for improved error handling. However, speaking about the disadvantages of I2C bus, I2C bus increases the complexity of firmware or low-level hardware. It also imposes protocol overhead that reduces throughput, and I2C bus requires pull-up resistors which limit clock speed and consume variable PCB real estate in extremely space-constrained systems. Hence, after knowing everything about I2C bus, let us now know its applications, that is, where they are used. Common application of I2C buses are: they are used for describing connectable devices via small ROM configuration table to enable plug and play operations, such as accessing real-time clocks and NVRAM chips that keep user settings, along with accessing low-speed DACs and ADCs and controlling LCD displays. And that was the end of the topic I2C bus. Thank you so much for watching this video. Don't forget to like, share and subscribe to Ekraft Geeks. Thank you so much and see you next time.